Have you ever pondered why time only moves forward, never backward? This question has occupied some of the greatest minds throughout history, and the answer lies in a scientific concept that is as mysterious as it is fundamental. That concept is entropy. Entropy is a principle that governs not just the farthest reaches of the cosmos, but the everyday experiences that shape our lives. It's the reason why your coffee cools down instead of heating up, why buildings crumble instead of spontaneously assembling, and yes, why time marches inexorably forward. But what exactly is entropy? At its most basic, entropy is a measure of disorder or randomness. Picture a child's bedroom. It's easy for the room to become messy, toys strewn everywhere, clothes piled up. But to tidy it up, to bring order, takes effort. This is entropy at work on a small scale, the natural tendency towards disorder. Now imagine this on a cosmic scale. The universe began in a state of incredible order at the moment of the Big Bang. But ever since, it's been moving towards a state of greater disorder. This is the essence of the second law of thermodynamics, one of the most fundamental laws of physics. It states that the total entropy of an isolated system, like the universe, can never decrease over time. It can only stay the same or increase. In practical terms, this means that processes in the universe are irreversible. You can't unscramble an egg, unburn a log, or rewind time. Every moment is unique, never to be repeated. And it's entropy that ensures this. So, entropy is not just a scientific concept, it shapes our very perception of time. It's the hidden thread that weaves the tapestry of the universe, the silent rhythm that beats in every atom, every galaxy, every moment of our lives. The universe and you, we're all dancing to the beat of entropy. This is the story of entropy, the force that drives the universe and, in a very real sense, dictates the flow of time itself. It's a story that's still being written, still being understood, but it's a story that affects every one of us, every second of every day. So, entropy is not just a scientific concept, it shapes our very perception of time. But what exactly is this entropy we're talking about? Great question. It's a term that's thrown around a lot, but what does it really mean? Well, in its simplest form, entropy is a measure of disorder or randomness in a system. It's like the universal rule of nature that things tend to get more disordered over time. Let's imagine your bedroom for a moment. At the start, it's perfectly tidy. You've got your books stacked neatly on the shelf, your clothes folded in the drawer, everything is in its place. But then life happens. You pull out a shirt to wear, a book to read, and before you know it, things are starting to look a little chaotic. This increase in disorder from a tidy room to a messy one, that's entropy in action. But entropy isn't just about messy bedrooms, it's a fundamental principle that governs the behavior of our universe. From the swirling galaxies to the tiniest particles, everything is subject to this rule of increasing disorder. It's the reason why you can scramble an egg, but you can't unscramble it. It's why ice melts into water, but water doesn't spontaneously freeze into ice. Entropy is also deeply connected to the flow of time. Have you ever wondered why time only moves forward, not backward? It's because of entropy. The increase in entropy gives a direction to time from the past, which is more ordered, to the future, which is less ordered. So entropy is a bit like the universe's accountant, keeping track of the balance between order and disorder. And just like a good accountant, entropy always makes sure the books balance in the end. It's a law of nature that entropy always seeks to increase, driving the universe from order to disorder, from past to future. Entropy, then, is the measure of chaos in a system, always seeking to increase. It's a law that governs not just the cosmos, but our everyday lives as well. It's the reason your room gets messy, your coffee cools down, and why time only ever moves forward. So next time you see a bit of chaos, just remember that's entropy doing its job. Why does entropy always increase, you may wonder? Well, to answer that, let's turn to the world of statistics and probability. Imagine, if you will, a deck of cards. When you first open a fresh pack, the cards are neatly arranged in a specific order. But what happens when you shuffle that deck? Each shuffle nudges the deck towards a more random state, a state of higher entropy, if you will. This is simply because there are far more ways for the cards to be randomly shuffled than for them to be in their original, neat order. The same principle applies to the universe. There are simply more ways for particles to be arranged in a disordered state than an ordered one. But let's delve a little deeper. You see, every time you shuffle that deck, you're not deliberately aiming to increase its disorder. Rather, it's a natural consequence of the sheer number of possible outcomes. For every one way the cards can be perfectly ordered, there are a staggering number of ways they can be disordered. So statistically speaking, it's far more likely for the deck to end up in a state of disorder or high entropy. Now let's scale this up to a universal level. The universe, much like our deck of cards, is constantly being shuffled by the forces of nature. And just as with the deck, there are far more ways for the universe to be in a state of disorder than order. As such, the universe naturally tends towards the most probable state, which is one of higher entropy. This doesn't mean that order can't occur or that low entropy states are impossible, far from it. Just as you might occasionally shuffle a deck into a perfectly ordered state, so too can pockets of order arise in the universe. But overall, the inexorable march of entropy continues. So the universe is like a cosmic casino, always betting on the most probable high-entropy outcome. It's a game where the house always wins, and the house in this case is the law of increasing entropy. So, what does this mean for us in our universe? Well, the ramifications are profound and slightly disconcerting. As entropy continues to rise, the universe is heading towards a state known as the heat death. This isn't as dramatic as it sounds. It's not an explosion or a fiery end, but rather a gradual fading away. Imagine a cosmic clock, slowly winding down until it can't tick anymore. In this universe, all the stars would have burned out, leaving behind black holes, neutron stars, and white dwarfs. The universe would be a cold, dark, and desolate place with temperatures approaching absolute zero. But don't despair just yet. This future is so far away that it's almost incomprehensible. For now, we can take solace in the fact that the arrow of time, the ceaseless march of moments from the past into the future, is intrinsically linked to entropy's relentless increase. Remember, every moment that passes, every second that ticks away, is a testament to entropy's relentless march.